All right, we are going to spend a couple of days just reviewing some concepts that are really important. When you get into the calculus part, there's a lot of complicated algebra. And so we want to just review a couple of things that kind of trip people up along the way. The first is to deal with radicals, okay? And so we are going to be simplifying some radicals in this problem. Um, I just want you to know that this number out here is called the index on a radical expression, and this number here is called the radicand. And we are going to break some radicals down and just sort of review that process here in a minute, okay? So obviously, I think you can do the square root of 36. Just remember that when there's not a number written, this is assumed to be a 2. Okay, so if you want to think about this as 36 is 6 squared, and then those two undo each other, and the principal root is 6, that works. Okay, here when you have a fraction, you can think of this as the cube root of 27 over the cube root of 8. Okay, this is really the cube root of 3 cubed over the cube root of 2 cubed. Okay, those cancel each other out, and so you just get 3 halves. Okay, when there's a negative there, the negative can go either place, but this is really the cube root of negative 27 over the cube root of 8. If you want to put the negative on the bottom with the 8 instead, that's fine. Negative 27 is negative 3 cubed, okay? And 8 is 2 cubed. And again, the cubes cancel each other out. So you get negative 3 halves, okay? The next example, when you take negative 625, this is what I will tell you. This is really the fourth root of negative 625. And here's the deal. If you, lots of people think, okay, well, that's negative 5 to the fourth power. And the problem is this, negative 5 to the fourth power, and negative times a negative times a negative times a negative will be positive 625. There is no number that I can put in here, take it to the fourth power, and generate a negative right there. So this one actually has no solution. Okay, it can't be simplified. It's not even legal, and you can't do that. Okay. All right, then here's a whole bunch of rules that I will just kind of let you peruse and look at, and we'll practice as we go through this. I know you remember a lot of these, but we will kind of break these down and go as we do this. Okay. This is the fourth root of 80. And what I want you to do is I want you to be able to simplify these. You can do this kind of in many, many, many different ways. But it might be smart if you need to, if you don't know your fourth powers, if you need to, and some of you can do this without this, but if you need to, prime factor it. So 80 is 2 times 40, 40 is 2 times 20, 20 is 2 times 10, 10 is 2 times 5, okay? Hopefully you can see that you have 4 2's here, so I can rewrite this as the fourth root of 2 to the fourth and then 5. Okay, I can think of this as the fourth root of 2 to the 4 and the fourth root of 5. This can undo each other or undo itself, so I'm going to have 2 times the fourth root of 5. And that's how that one gets simplified. Okay. On this next one, you're going to think of taking, and again, there's a 2 right here, okay? So you're going to think of simplifying the square root of 18 and simplifying the square root of x to the 5th, okay? I think square root of 18 you can do. This is really the square root of 9 times 2. Okay, so this becomes, and I don't know why I'm writing those 2's there, but the square root of 9 is 3, and then I have the root 2 here. Okay, when I simplify the variable piece of it, you can rewrite these as fractional exponents instead. So if you remember how to do that, this number is your numerator, and this number is your denominator. Okay, and if you think about that, x to the 5 halves, I'm just going to do this off to the side, is really x to the 2 1/2 power. This number tells you what goes on the outside. This number tells you what goes on the inside. Okay, so this is what I have. I have x squared and then the square root of x. Okay, again, I got this number from here. It became x squared. And I got this number, which is a 1, from this one right there. Okay, so that's how I got those. I'm going to combine that. Some of you can do that all in one step, and if that's you, that is fabulous. I'm going to combine what's on the outside. So what's on the outside is a 3 and an x squared, and what's on the inside is a 2 and an x. Okay, and again, if you can do that in one step, that is fabulous. All right, then over here, you can kind of think of this as the fourth root of xy to the fourth power. Okay, what I want you to notice is this. When you have an even number here and an even number here, you do have to do absolute values. Okay, and the reason you have to do absolute values is this. Like if I asked you to take the square root of 16, okay? Really, what I know is that 4 squared is 16, so I really could do this and get 4, or I could do this because -4 squared is 16, okay, and get -4. So what we're doing is saying take the absolute value of that so that it accounts kind of for both cases, okay? That's what happens when this is even and this is even, okay? So here I'm just going to get the absolute value of xy. Excuse me. All right. In this next one, okay, we're going to break the number and the variable down separately, but we're not going to write it separate because I think you can handle this. This is the cube root. 24 is 3 times -8, okay, and then I have y to the 6th power. Well, the 3 I can't really do anything with, but -8 is -2 to the 3rd power, okay? And y to the 6th is y squared to the 3rd power. Okay, if you want to think of those as fractional exponents instead, like I did in the last example, that's totally fine. Okay, these two will cancel each other out, and then we'll be able to pull that -2 out in front. These two will cancel each other out, and then we'll be able to pull y squared in front. But I can't take the cube root of 3 and have it be a whole number. So that's where I need to end up on that one. Okay, then we're going to do some more practicing with rationalizing the denominators, which I know you've done several times, but we'll do it again. Okay, when you have a fraction, you really have the square root of 2 over the square root of 3. Can't leave a radical in the denominator, so remember that you'll multiply by root 3. Across the top, I can multiply root 2 times root 3 is root 6. On the bottom, root 3 times root 3 is technically root 9, which of course you know is 3. Can't reduce that fraction because you have one number inside the radical and one number outside, and you can't reduce those. Okay? Excuse me. The next thing you're going to want to do is this. Again, you can't have a radical in the denominator, and what you need to think about doing is you're going to multiply this by the 4th root of something. This is x to the 1 right now. Because this exponent is a 4, you need to have a multiple of 4 as your exponent on your x's. Okay, so I'll explain this. This is going to be x. I'm going to make this x to the 3rd power so that 3 plus 1 makes 4. 4 is a multiple of 4. If I wanted to make it a power, if I wanted to make it 8 or 12 or 16 or something, that's what I would need to do. But I need to add x to such a power so that when I add what I already have with it, it becomes a power of 4 since this is a 4th root. Okay, if it was a fifth root, I would add it so that it became a power of 5. But it's the fourth root. And whatever I do to the bottom, I must do to the top. So that's what I will do here. 1 times the fourth root of x cubed is just the fourth root of x cubed. On the bottom, I now have the fourth root of x to the fourth because I have x to the 1 here and x to the 3 here. So this becomes x to the fourth here. And then, of course, these will undo itself so that you don't have a radical in the denominator. However, you did have an even exponent with an even power. And so I do need to make sure that I say that it's the absolute value of x down here. And then the fourth root of x to the third. Okay, and we will do one more. So this is the fifth root. So I will take the fifth root of x squared on the top and the fifth root of y to the third on the bottom. Okay, so now since my index right here is a 5 and I already have 3 y's right here, I need to add enough y's so that my total becomes a number that is divisible by 5. So I am going to add y squared so that y to the third and y squared makes y to the fifth, which is obviously a power of 5. If I do that to the bottom, I have to do that to the top. Okay, so when I put the top together, I end up with the fifth root of x squared y squared over the fifth root of y to the fifth. And then, of course, these two cancel each other out. And I get the fifth root of x squared y squared over just simply y. Don't need it to be an absolute value because this is an odd index right here. So I don't need to do anything with that. Okay, so that's how that goes. And then, of course, you can sometimes write radicals as fractions, and so we'll practice that real quick too. Basically, the number, first of all, if you're missing a number, this is a 2. So you're going to take what's inside, this becomes the numerator, and this number right here is the denominator. Don't think that the denominator is 1. When you're dealing with radicals, if a number is missing, it is definitely 2. Okay, so I can just quickly rewrite this as x plus y to the 3/2 power. Okay, here the only thing I can put as a fractional exponent is this piece. So I have 3x times x to the 2/5 power. And then you can simplify those x's. Remember there's a 1 right here. When you have two bases, you add your exponents. So this really becomes 3x to the 1 plus 2/5 power. Well, 1 is 5/5. So 5/5 plus 2/5 becomes 7/5. And that's how that one should look. All right. A couple more here. You're just going to convert these to the other form so that you can get this. This is really here. If I do just this part of it, this is the cube root of x squared. And this is the cube root of y to the 1. Okay, I can put those into one cube root and make this be the cube root of x squared y. Okay, and I want you to remember that when you have negative exponents, it does not mean that you put a negative out in front. It means that you make it into a fraction. So this is 1 over z to the 3/2 power. Okay, which is the same as 1 over the square root of z cubed. And I'm not going to ask you to rationalize the denominator here. I'm just saying, I just want you to be able to convert it from one form to the other. So that's all you have to do there. Okay. Here, when you're raising exponents to a power, like this and this, you only have one base, okay, with two exponents. And so you're going to multiply those. So this becomes x to the 2 times 1/3. So x to the 2 times 1/3 is x to the 2/3. And then y to the 9 times 1/3. 9 times 1/3 is 3. Okay, and then of course you have x and you have y squared over here that you haven't done anything with. Okay, then you're going to take your x's and you'll add your exponents. So this is because I have more than one base. Okay, more than one base. This is x to the 1. So I'm going to add those. So I have x to the 2/3 plus 1. And I have y then. Here's my y's. Y to the 3 plus 2. Okay, 2/3 plus 1 is 2/3 plus 3/3 if you get common denominators. So 2/3 plus 3/3 would be x to the 5/3 and y to the 5th. Okay, couple more and we're done here. Here's another one. Okay, we are going to multiply these across the top. Okay, when I multiply these across the top, I will multiply my coefficients. So 3 times 2 is 6. I will add my exponents since I have more than one base. Okay, so I will add 2/3 and -1/2. If you add 2/3 and -1/2, you can get the common denominators and get that onto your calculator. But 2/3 and -1/2 becomes x to the 1/6. Okay, on the bottom, I will take y, and then I will add 1/2 plus 2/5. So 1/2 plus 2/5 becomes y to the 9/10. All right, and then of course we can take radicals and combine them as well. Okay, and when we combine them, we want to break them down as much as we can. Since this is a 2 right here, we're looking for numbers that are in a power of 2. So I would break this 80 down into 16 times 5. Okay, then this becomes, oh, I should pull this out. This, and I don't know why I'm putting the 2 right there. I don't need to, or I don't need to put the square root, I should say. I am going to put this 2 here, but I'm not going to put the square root. Okay, square root of 16 is 4. So this becomes 2 times 4. Square root of 5 is not a whole number, so this just becomes 8 root 5. Okay, now I deal with a -125. This is the same as the square root of 25 times 5. Square root of 25 is a whole number, so that's 5 root 5. Okay, now I'll just bring this down right here so that we can see this. If we have 8 root 5s minus 5 root 5s, I can simplify those. In order to add and subtract them, you do have to have the same number underneath the radical, which I do. So if I have 8 root 5s minus 5 root 5s, I end up with 3 root 5s. Okay, and the very last one. Here again, you're going to simplify these a little bit. Okay, the square root of 4 is 2. Then you're taking the square root of x squared. There's a 2 right here, remember? Those two cancel each other out, but remember you're canceling an even with an even, so you need to have an absolute value symbol in there. And then the square root of y, I can't do anything with. Okay? Over here, I can think about this as the square root of y squared times y. Okay? These two can cancel each other out because, but again, I have an even exponent with an even power. So I'm going to do absolute value of y. And then this y I can't do anything with, so I need to leave it inside. Okay? So notice they both have a square root of y in there. Okay, they both have this in there. So I'm just going to simplify this and do 2 absolute value of x minus absolute value of y, all of that. Okay, I'll put it in parentheses even. All of that in front of the square root of y. All right, and that should do it for today.